Okay, gang, in this lesson, we're going to spend a little bit of time reviewing before we get into our next major topic. So I've written myself some notes along the side here of things I just want to briefly mention to make sure that we're all on the same page. So the first thing I want to do is I want to remind you of some important concepts that will continue to reappear throughout our conversations about electrocardiology. So remember this concept of automaticity, right? So automaticity we've talked about before, and remember the root word here is automatic. And so what that tells you is that cardiac cells have the ability to act as pacemakers, right? And so that turns out to be very important as we continue on in our conversation. And then with that, remember that these cells can also be conductive. So they're pretty unique in the sense that they can instigate electrical activity or they can conduct electrical activity. And then I also want you to remember that after we depolarize, and remember depolarization is signified here by the Qrs complex. This is depolarization of the ventricle. Remember this P wave here is depolarization of the atria. But when we repolarize here in the T wave, remember we'll cut this in about half, and over here is the absolute refractory period. And remember what the absolute refractory period means. It means that no matter what I do, I'm not able to create conduction because I'm still repolarizing, recharging that cell. But over here in the relative refractory period, at that point I'm recharged enough that I can go ahead and depolarize. Okay, so those are just a brief reminder of some stuff from our earlier lessons. And then a couple other things that are worth discussing would be these. So I want to remind you, kind of like we're talking about vocabulary here, I want to remind you of these complexes within our cardiac cycle. So remember, we have the P wave, which is atrial conduction, depolarization, right? Then we have the Qrs complex, where the Q is the first downward segment, the R is the first up, and then the S is the next down. And if you have another up, it would be another R. We call it R prime. So this is the Qrs complex, which represents ventricular depolarization. And then the T wave here, which represents ventricular repolarization. And of course, we've talked about before the fact that atrial repolarization is occurring somewhere in here, so we don't see it represented graphically on our paper. And then the other thing that's going to be important as we continue our conversations is to make sure that we really understand what intervals are. Okay, so the intervals that we're going to spend most of our time talking about would be the PR interval, which is the start of the P to the start of the Q. And just as a reminder, and we'll talk about this more, a normal PR interval is less than 200 milliseconds or one big box. Okay, and then the Qrs complex, in general, we want it to be less than 120 milliseconds or 3 small boxes. And then here we have our ST segment, which will become important to us later. Of course, we have our T wave here, which represents repolarization, and later we'll talk about things that can impact our T wave because they interfere with repolarization. And then finally, I want you to think about this QT interval here, at the start of the Q wave to the end of the T wave. And later as we go, we'll talk about why the QT interval is important. But I want you to constantly be reminding yourself, what do these mean? The P wave, the QRS, the PR interval, where is the ST segment, where is the T wave, what is the QT interval. Okay, I want you to constantly be thinking about these things, and just take a brief 10 seconds every time you sit down to study to just drill this into your head, but not only drill it into your head, but try to understand what it is that we're looking at, so that when you're reading an EKG at 3 o'clock in the morning, you'll be able to make sense of it. Another thing I want to review briefly is we talked about ways to calculate heart rate. And so remember, it takes 5 big boxes to make 1 second. And so because of that, we can do some mathematical rule making. And so basically we can look at this and we can say if 2 R complexes, so R to R interval right there to right there, if these 2 R to R intervals are separated by 1 big box, the heart rate's around 300. If they're separated by 2 big boxes, it's 150, 3 is 100, 4 is 75, and 5 is 60. And if you want to check your math, all you have to do is take 300 and divide it by big squares. Or if you prefer to get a little bit more down and dirty, you can take 1500 and you can divide it by small squares, and that's going to get you a really accurate analysis of the heart rate. But one of the things that's important to think about, and I'm sure I did not do a good enough job explaining this earlier, is that when we look at heart rate from beat to beat, it only kind of works if the rhythm is regular. Okay, so if it's regular, you can certainly look beat to beat and get a very accurate representation of heart rate. But what happens when your heart rate is irregular? So I'm going to show you an example down here. So this is an example of sinus arrhythmia, and we'll talk more about it in a minute. But for the purposes of our conversation on rate, you notice that the rate between here and here is 1, 2, 3, 4, 5 boxes. So that's 300, 150, 175, 60. The rate here is 300, 150, about 75. The rate here is probably, let's see, about 75, and then the rate goes back to about 60 here. And so it makes it very difficult to calculate rate if you're trying to do it beat to beat. So what we can do then is we can look at this and we can say, well, because I know that 5 big boxes equals a second, I can count up the number of seconds in this strip. And it turns out this is a 6-second strip, and oftentimes when they give you a strip to look at for practice, it'll be 6 seconds. One of the things they'll sometimes do that will be exceptionally helpful is they will give you these little hash marks here, and each hash mark to hash mark is 3 seconds. So if this is a 6-second strip, and I count up the number of Qrs complexes, which is 1, 2, 3, 4, 5, 6, 7, and I'm going to leave this one out because it's outside of my 6 seconds. So I've got 7, and if I've recorded 6 seconds, then I know I can multiply that by 10 because 6 seconds is in 60 seconds 10 times, right? So that means the heart rate is approximately 70 beats per minute. So we can do the same thing here, and this one is more straightforward because I know that this is regular and this is a rate of around 150, but let's just count these up. Let's assume this is a 6-second strip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if that's a 6-second strip and I've got 17 of those, the rate's going to be 170. So that's one of the ways you can also calculate rate if there's some beat to beat variability. The reality is, in clinical practice, what I want to know is really pretty simple. Is it too slow? Is it too fast? Or is it just about right? Because the reality, as we'll learn as we progress in our lessons, is that with some rare exception, it's not usually the rhythm that kills people, it's the rate. Okay? So it's very important that every time we look at one of these strips, we look at the rate and we decide, is it too fast, too slow, or just about right. So today's lesson, the new material, is actually going to be very simple, but it's very important, and it's going to be the foundation for everything we do moving forward. So what we're going to talk about today is we're going to talk about the necessary markers for sinus rhythm, for normal sinus rhythm, and then we'll talk about a couple of variations. So when we talk about sinus rhythm, we call it sinus because we believe that originates at the SA node. And so remember, the SA node sits up here in the right atrium and is the usual pacemaker of the heart. And so because you know that the SA node sits up here and is the usual pacemaker, you know that the usual heart rate for the sinus node is 60 to 100. So in general, when I say is the rate about right, if it's in there, it's about right. And if it's less than 60, we're going to call this bradycardia. And that's going to be true no matter where the origin of the beat is. But anything less than 60 is called bradycardia. And anything more than 100 is going to be called tachycardia. Okay, so just about right, we'll call that normal. And then anything faster than that is tachycardia, slower than that is bradycardia. So as we look at this rhythm right here, this is an example of normal sinus rhythm. Okay, it's called normal because the rate is normal, so let's go ahead and see what this rate is. So using any one of our calculating methods, let's see, 300, 150, 175. So this rate is 75, so that's definitely in the 60 to 100 range, which makes it normal. What I want you to notice is that we have a P wave before every QRS complex. Okay, see where I'm circling P wave before every QRS complex. And that's going to turn out to be very important. So let me erase this over here. I'm going to write some criteria down. So we'll say P before every QRS. Okay. Now the other thing I want you to notice here is we have a QRS after every P wave, also very important. So we have a QRS after every P. Okay, now let me erase some of my scribbles so you can see what we're doing. The other thing I want you to notice is that this is very regular. Okay, so when we go from here to here, the distance is approximately the same as it from here to here, and here to here, and here to here, and here to here, and so forth. So this is regular rhythm. Okay, there's not any more than about 10% of variability. Okay, the other thing I want you to notice is about our QRS complex. If we look at the width of our QRS complex, this is what we call narrow. And narrow means it's less than 120 milliseconds or 3 big boxes. So I'm going to zoom in on this. Okay, and our QRS complex is here, which is the distance from right here to right here. So we're looking at about 1.5 small boxes at most. Okay, so this definitely meets criteria to be narrow. Okay, so we have a normal rate, we're at 75. We have a P wave before every QRS, QRS after every P. We have a narrow QRS complex. Okay, these are the criteria that you need for a normal sinus rhythm. You can have sinus rhythm that is otherwise normal rate, but if the QRS complexes are wide, it's no longer a normal sinus rhythm. And it's important to make that distinction as we continue on in our lessons. Okay, so this is normal sinus rhythm. I'm just going to drill this in. I'm going to say it till you get bored with it. So normal rate, regular rhythm, less than 10% of beat-to-beat variability, P wave before every QRS complex. That means every QRS complex is preceded by atrial depolarization. Okay, that's the significance of this. And then we have a QRS after every P wave. That means every time I depolarize the atria, it's getting conducted through the ventricle. Okay, so P before every QRS, QRS after every P, regular rhythm. QRS is narrow, by which I mean it's less than 120 milliseconds. Okay. So as we move on, I want to go to this next one here. And this is an example of sinus bradycardia. Okay, let's see if we can figure out why. Okay, so as I look at the rate, this is a pretty slow rate, isn't it? So let's see what this rate is. This is going to be somewhere in the 40s, I would guess. So 300, 150, 100, 75, 60, 50. So this rate's somewhere in the 40s, maybe probably more like the 30s. So we have a slow rate, definitely less than our normal rate of 100. Okay, it's regular. There's no beat-to-beat variability here, so it's regular. We have a P wave before every QRS complex. We don't know for sure that we have one here, but on the ones where we can see the entire QRS complex, there is a P wave before every QRS. So a P before every QRS, and then we have a QRS after every P wave. And what's the importance of that? Just to remind you, P wave means atrial depolarization, and if there's a QRS complex after every one of those, that means all of our ventricular beats are preceded by atrial depolarization, and it also means that all of our atrial beats are being conducted, none of them are being blocked. Okay, this will be very important in our next lesson, so make sure you understand this concept. Okay, so this is sinus Bradycardia. So this is normal sinus rhythm, or NSR. This is sinus Brady, right? And it's Brady because it's slow, but it's otherwise normal with P waves and QRS complexes. So as we move down here then, more of the same. Okay, so we look at this, and just by eyeballing this, without trying to calculate any rate, we can tell that this is too fast, right? And so by looking at this, we're going to guess the rate is a little over 150. I think we calculated it at 170 before. So it's fast, real darn fast, okay? So we know that fast things are called tachycardia, so we're going to call this tachy. We see, I'm going to zoom in on this to make it easier to see here. So there is a P wave before every QRS complex, and there is a QRS complex after every P wave. So remember our rules, right? So you've got a P before every QRS, you've got a QRS after every P, we've got narrow QRS complexes. Okay, these things are very narrow. They're probably less than one small box. Okay, and really we have to zoom in to see that well, don't we? Because it's going so fast. But this is less than one small box from here to here. Okay, so we have a narrow QRS complex. We have a regular rhythm, not very much beat-to-beat variability. Okay, so this is called sinus tachycardia. So this is sinus tach. Finally, what we have down here is sinus arrhythmia. Okay, sinus arrhythmia is the one I showed you at the very beginning, where it's a little more difficult to calculate the rate because of the beat-to-beat irregularity. Okay, but on this one we figured out earlier that our rate's probably somewhere around 70, which is good. So it's a normal rate in this case. We do have a P before every QRS. We have a QRS after every P. But when we look at our beat-to-beat variability, right, there's quite a bit. So all of these beats meet criteria to be sinus beats, but there's quite a bit of beat-to-beat irregularity. So this is called sinus arrhythmia. Okay. Most of the time we see sinus arrhythmia in younger people, and oftentimes there's a pretty clear connection between the respiratory pattern and the beat-to-beat variability. Okay, and so a lot of times if you're looking at these folks on the monitor, you can actually predict when it's going to speed up and slow down based on their respiratory pattern. So this is sinus arrhythmia. Okay, so what I want to do then is I just want to take a minute to recap what we've been talking about today in our lesson. Okay, as I told you before when we got started today, that this lesson is very important, even though it seems like it's very simple, because this is the first set of criteria we're learning, and it's the basis by which we're going to hopefully understand other dysrhythmias and be able to figure out what's going on. Okay, because this is more about not just memorizing what a rhythm looks like, but understanding why the rhythm looks the way it does. Okay, so I want to just spend one more minute talking about normal sinus rhythm. So normal sinus rhythm, this guy right here. Okay, let me zoom in. So P waves, boom, 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 P waves, atrial depolarization. Okay, so that means the pacemaker is in the atria, and we presume it's the sinus node. Okay, so we have an atrial pacemaker, and then we see that it's being conducted into the QRS complex, and that means it's going from the SA node to the AV node and into the ventricles. Okay, one other thing to kind of bring up, which will be more important later, and I didn't mention to you this morning, but which theoretically and technically is another part of the criteria. It's important when we're looking at this idea of the P before every QRS and the QRS after P. I want to know the distance from the start of the P to the start of the QRS complex. And remember, we talked about that being the PR interval. The PR interval in a normal sinus rhythm is always going to be less than 1 big box or 200 milliseconds or 0.2 second, okay? And we will talk more about that in our next lesson as to why that's important, and we'll spend quite a bit of time focusing on that, okay? But let's go ahead and add that to our criteria for normal sinus rhythm. Okay, so we're going to look at our rate, we're going to look at our rhythm, we're going to look at our PR interval, okay, our QRS complex, and we're looking at sizes here. And then what we want to know is there a P before every QRS and a QRS after every P. Okay, so between now and the next lesson, drive that information home, and then we'll talk about later why all these little things are important. Okay, so there it is, sinus rhythm. So normal rate, 60 to 100. It's regular. It has a PRI less than 200, a QRS complex less than 120 or 3 small boxes. It has a P before every QRS. It has a QRS after every P. Okay, normal sinus vanilla rhythm, the most important rhythm to learn because it's the one from which all others will be identified. So that's all I have for you in today's lesson. If you have any questions, please reach out to me through any variety of techniques, and we'll talk to you again soon.